Hi folks, CodeTutor here and my name is Anil Deshpande. Welcome to the next video on Kotlin Coroutines. One of the statements that I had made in the previous video was with coroutine it is purely a programming construct. That statement was not a passing statement. In this particular video, I want to spend more time on this particular statement. So just going by what I had said, question is what does it actually mean? Well, if you look at the code that we had written in the previous video, we have used the usual coroutine related keywords like suspend, delay, run blocking, async. And at the end of the day, we have imported classes from Kotlin X coroutines package. And that is how we were basically able to implement a coroutine. And not only that, we used this to make sure that the behavior was being run on a main thread. Now, when I say that coroutine is purely a programming construct, does that mean I can still achieve this particular behavior even without coroutines? That is, even if I remove all these things, can I still achieve coroutine without coroutine code? And if I am able to do that, that basically proves that coroutines are purely programming constructs. So let's try to understand this through a demo. This is the same old code base which is written using Kotlin coroutines. Now what I have done is to demonstrate this, I have transferred this particular code to Android application. It is easy to demonstrate this in an Android application. Why? We will come to know a bit later. So let me open Android Studio. So if you see here, this is my coroutine. This is my long running work, which is a suspend function. And if you have done even a little bit of Android programming, you know you have a activity, and in that activity you have got a lifecycle method called as onCreate. So you can think for all practical purpose this is your main function, which is the entry point of your program. In that I am calling my coroutine using the coroutine scope launch. If you don't understand this job and coroutine context, it's perfectly fine. For all practical purpose, this is the coroutine invocation, just like you had invoked it in the main function in the earlier program, and this is the coroutine function. And if I run this, it will run in a emulator. I am not interested in seeing how it behaves on the emulator. I am just interested in whether I get the same behavior that I was getting in the main application some time back. So just pay attention to what's happening in the logcat. Logcat is basically the place where you see the output of your application if you had logged anything. So you can see that you are exactly getting the same behavior that you had seen in the IntelliJ IDE, that is main activity started, main activity thread ended, and our coroutine kept on running even after the main activity had ended. I mean, main activity has not really ended because if the activity is visible on the screen, it is still running. Now, when I say that can I get the same behavior even without coroutines? So let me demonstrate that. First of all, let me remove this suspend function, and if I do that, the delay is no more valid, and then this is not needed and launch is not needed. This is just a normal function invocation. However, if I run this now, you will get a compilation error because it has a coroutine scope. So let me remove that as well. Any reference to coroutine that exists in the code, let me remove that to make it absolutely sure that this is the code that doesn't have any reference to coroutine library. And now let me have a look at the logcat. My application should be able to run, but this one will not even actually get you the same behavior. So that is the reason why if you observe, you will see main activity started, then coroutine thread started. It is just a simple function invocation right now, and then main activity thread ended. So this is basically a blocking code execution, which is of no use at all. Now the thing is, how do I get the same behavior as a coroutine without actually using a coroutine? So what I can do is, for that I will use the concept of handler and a looper. If you are not familiar with handler and a looper, I suggest that you watch one of my earlier videos where I have explained the handler and looper concepts very clearly. And handler and loopers can be used within the context of Android operating system. So that is the reason why I would not have been able to demonstrate this in a normal IntelliJ IDE, which doesn't have access to the Android OS. However, in Android Studio, which is basically the development environment for Android, I can use the handlers and loopers. So how does this go? So let me just stop this. What I can do is, inside the for loop, I can write handler, which is part of Android OS, and then I will get looper reference inside that, that is looper dot get main looper, and then I will write post delayed, and inside that I will write a runnable instance, which is basically like implementing a runnable interface. Let me take a moment here. It looks like it accidentally imported the runnable interface from the Kotlin X Coroutines package. However, later I replaced it with a normal runnable interface and the application still works perfectly fine. So you need not worry about that. So let's continue. And then invoke it after, say, no delay, zero delay. And whatever the code that I had written here, I will put it inside this runnable instance. But then I should get a delay behavior. For that, what I can do is I can try thread.sleep method, that is thread.sleep, but for that I have to catch a interrupted exception here, and if something goes wrong, I want to basically log it, and then inside this let me write thread.sleep and pass the delay, and then put this under the delay. And if you have seen this particular code now, this doesn't use anything related to coroutine. There is no delay, there is no suspend function. Everything is purely written in a normal plain Kotlin code without coroutines. And if I run this, you can see that the main activity thread already has ended, and then the sample coroutine is running after that, and it is also still running on the main thread, and this is exactly the same behavior. I think these are two lines which are repeated, so let me remove this and let me stop this and run again. So you can see that the main activity start and end statements and then the coroutine, and it is also running on the main thread. So what does this mean? Whatever the delay function that we would have written using the coroutines, we are basically able to get the same behavior using the handler dot post delayed functionality, and internally delay implementation also uses the handler and post delayed or certain flavor of a post delayed to get the same behavior as coroutine. Now the obvious question you would be asking is, why not use this rather than learning the concept of coroutine? It's all about convenience. Writing this much complicated logic to get a coroutine behavior is really complicated, and then coroutine also provides a lot of other convenient mechanisms to deal with multi-threading and scheduling. Doing it manually on your own and understanding all the internal nuances of how to get that behavior using the handler and looper can really become cumbersome, and that is the reason why it is better to learn coroutine rather than trying to implement your own mechanism using handler and looper. Coroutines are not really a magic. They use the older programming constructs that are already present in Java and Android and use that to deliver a very convenient and crisp way of writing async code in your application. And that's the reason why you should learn code. That brings us to the end of this particular video. Don't forget to like, comment, share the video and subscribe to the channel. Take care. Bye.